Hello everyone, we're going to do the last unit of this robotics project course. Let's have a look. For the overall planning of this robotics project course, we hope that by the time we enter the final stage, we can do some evaluation by means of completing stages. In our evaluation, the parts we use are actually not complex. There are quite a few simple parts. We expect you to make use of these simple parts to make a complex final work. We have arranged 4 stages. For these 4 stages, if possible, we would like you to challenge these stages, one after another. You can also consider your preparation time and choose to challenge 1 to 2 stages. This is what I think. Instead of clearing all stages, it's better to aim for 1 or 2 stages with the best results possible. I think that during these 18 weeks period, you can focus on 2 stages and try to understand them fully and write a good learning portfolio. If you can go over all of the stages at least once, I believe that you will have a comprehensive understanding in robotics. Let's have a look. These are the stages that we have prepared. Stage 1, snatch the ball. Stage 2, maze walkthrough. Stage 3, robot combat. Stage 4, transport the ball. These are the stages prepared. How will we carry out these activities? I'll tell you about the steps. First, before you begin, you need to familiarize yourself with the rules. This is very important. Why? If you don't understand the rules, it'll be like writing an essay with the wrong topic. So you must familiarize yourself with the rules. You must observe the problems that you need to solve. That is, you need to figure out what are the problems that you need to solve in these stages. Secondly, you need to have a look at the competition ground. The rules are written in text, but you need to use your eyes to observe the competition site. You will have a greater notion of the stage's difficulty and size ratio. Many students wait until the last minute. The proportion will be high until the last minute too, and notice that the size ratio is wrong. When you're doing the second stage, you must first check the site that the teacher has provided. Third, after reading the rules and problems, you can research the best competition strategy according to the different scoring methods and come up with the best strategy. Next, you'll need to discuss and come up with at least 3 feasible solutions. After that, you move on to the 4th stage, which is to share and discuss your ideas with your team. Before you begin, you should not rush it. You need to think thoroughly. Each of you should do research about the information related to your idea. After doing research, each of you shall give an explanation. During the explanation process, you will have a clearer idea about this competition. After everybody shares their ideas, you can check how others are thinking. This is a very important phase. Why? At this time, you are not competing to see who has the best idea. What we're doing in this stage is brainstorming and complementing ideas. Others may have thought of something you have not, and take it in for yourself. What was done poorly by others, you can help correct them and improve upon it. Expand your thinking and make corrections to others' wrongdoings, as well as yourself. Gather all the good ideas. This is what this stage is all about. When the strategy is done, you move on to the 5th stage, which is rapid prototyping. During this rapid prototyping phase, it emphasizes on speed. So at this stage, you can use simple corrugated paper or foam board to quickly produce your idea and confirm whether your idea is correct or not. At this stage, you need to verify whether your idea in the 4th phase is correct. If it's correct, then keep it and move on to the next step for testing. If you find any problems during the testing, or you realize during the 5th phase that is difficult to achieve your goals, then you need to go back to the 4th phase and find another good idea again. The 6th phase is about testing and find out if there are any problems. If there are problems, then correct them and go back to the 4th phase and think again about how to solve the problem. If it is a minor issue, you can continue. But if it is a big problem, you need to go back to the 4th phase. After the 6th phase is completed, you can then move on to a more final work. Do not attempt to finish the fourth phase at once and move on, or the reliability of this final work won't be so good. I suggest that you make a cycle between the fifth and sixth phase. Make 1 or 2 corrections to obtain an optimized design and produce the final work. Before you begin, let me give you this idea. Let's move on. The practical production will be after the fourth step. Do rapid prototyping in the fifth step and testing in the sixth step, and you can cycle between these two. We'll begin our practical work and produce an actual workpiece. We will have a practical order. During our practical project, its structure will be like the course we had. It will be divided into 3 sections: electric control, chassis, and mechanism. These 3 main topics. When making a robot, it usually won't go past these 3 topics. A robot within this whole system, when we were planning the whole lesson plan and the educational activities, we thought about fixing the electric control system and define the parts that we'll be using. This way, when you're developing your ideas, you'd be using this fixed control system setup and use less time in this area. If you really need to make changes to it, you'll have to dismantle it. You consider the assembly of your structure and mechanism is not convenient. You can dismantle it. But if you dismantle this part, you need to be fully confident with the circuit structure to do this. If not, we'll continue to use the original structure. What will be easier for you to get creative is the second phase, which is the chassis design. The design of the chassis will involve the problem solving of these 4 stages. You may do some modifications. Why? Because the chassis of a 3-wheeled vehicle is suitable for program control applications. But when you use it for task-related applications, you need to consider its center of gravity problems. You may need a new chassis configuration for the vehicle. At this stage, you can disassemble it if you require it. That's why, during our initial design, we grouped the motor and the wheel as an assembly. You can modify this 3-wheeled vehicle to 4 driver wheels or 2 driver wheels with 2 follower wheels to redesign the chassis. It depends on your need. Of course, you can still use the original chassis. After you dismantle the chassis, it is still a viable one, so it depends on your need for solving the problems. For this chassis, I suggest that you think about the topic first. Whether you disassembled it or not, it's up to the topic's requirements. Next is the part where most changes will be made, which is the mechanism part. We've talked about the mechanism choices in previous lessons. When choosing the mechanism, the first thing is to confirm what kind of power source you'll be using. You can use a motor or a servo. Once you've decided on the power source, you need to decide the mechanism variation based on the given task. Do you need a circular motion, a linear motion, or a regular oscillating motion? You need to match with the type of mechanism to do the design once your power source is determined. The next step is to change the structure and mechanism accordingly. This part will depend on what you have learned throughout this course. After absorbing this knowledge and turn it into an idea of your own, then consider the idea of others. Further develop the idea based on the topic given. Once your electric control system, your chassis, and the mechanism responsible for the carrying out the task are completed, you assemble them together and need to actually operate it to test out whether your initial idea is working as you expected. During this practical process, we need to think about how to modify it. There are a few things we can consider. First, did the robot complete the expected motion, what you expect it to do, whether it is its vertical or horizontal motion, as well as the gripping motion? Is the effect good? Second, when operating, you need to pay attention to one thing. After the operation, is the voltage attenuation fast? Every time you operate and cause a normal or abnormal voltage attenuation determines whether the operation of the parts during this process is suitable or not. You also need to consider this, especially for programming level robotics competition. The power output of the motor is related to its voltage. If the voltage attenuation is fast, during each competition, the motor's speed will vary. You need to pay attention to this, especially when it comes to self-controlled programmed robots. You need to pay attention to the degree of voltage attenuation. These are all that you need to pay attention to. Third, check if the temperature of the motor control shield and the servo are normal. Why? Because if the temperature rises, it means that their working power is too large. Maybe your mechanism is not working smoothly enough, so the motor needs to output more power than it was originally intended. This situation can cause the overheating of the motor control shield. In severe cases, there will be burnout. In light cases, the system will crash or work abnormally, so you need to pay attention to the temperature. Someone may ask you how we are supposed to measure the temperature. Of course, a more scientific method would be to use an infrared thermometer for a safer measurement. Don't attempt using your hand to touch it, alright? Sometimes it's really hot. Definitely do not touch it with your hands. You need to use an infrared thermometer to measure it. Fourth, is the working speed fast enough? This problem often occurs with the chassis, because the selection of the reduction ratio of the moving motor will involve the weight of the vehicle, the friction on the competition site, and the wheels. It is difficult to use calculations to obtain a suitable working speed. So at this time, our usual method is to choose the most common speed ratio. Then, after the testing, we'll see if it's working as expected. If it does, then congratulations. You are quite lucky. You don't need to make adjustments. But if it's not, you'll have to make adjustments. When you are started up and it feels hindered, what does this mean? It means that the torque is not enough. In other cases, the torque is enough because it is very smooth during startup, but it's slow as a turtle. Is this good? This is also not good. The choice of speed reduction ratio is very important. Sometimes the budget needs to be taken into account, as well as the needs of the competition. You need to find a suitable configuration. Fifth, is the structure stable enough? For the robotics competition, when the robot is moving, it actually experiences intense vibrations. Choosing the screws may be an issue. The screws should not loosen easily. Even after you screw it, it gets loosened. It means that when you were designing the structure and mechanism, you did not reinforce parts that needed reinforcement. You can observe during the operation if the structure is stable. If it is not, you need to think how to modify it. Last one, is your mechanism easy to control? Since the competition is about completing tasks, if you have an easy control, then you can score faster. For this part, in addition to having a good mechanism design, the remote control program needs to make up for the initial mechanism design shortcomings. When comparing robots, there is a saying, if you have a good mechanism design, the programming becomes easy. If you have a bad mechanism design, when you are writing the program, you'll need to spend more time thinking how to make up for the mechanism design problems. Of course, if you can take care of these two and correct their issues, I think this is what makes a good robotics team. The mechanism design needs to be good, and the programming is written well and present its most optimal state. This is considered a good robotics team. Next, let's talk about footprints in the sand show where one has been. What is the shown? Your learning portfolio. Next, we'll be talking about how to write our learning portfolio. The learning portfolio is to let the students record the process of the project, how you think and how you develop. At the same time, it is also expected that students should use their brains to think besides the practical work. because these two factors are equally important. Having something done right is not only up to your hands-on skills. You have to think about whether there is a more efficient option and easier to make. All these things can be written into your learning portfolio. While recording, you can also think about how you are going to deal with the same issue happening in the next round. Is there a more efficient way? This is also a very important point on the learning portfolio. First, let's have a look at what needs to be written in the portfolio. You can actually begin writing these things while completing the challenge stages. In this project, first, when you're challenging the stage, what is the objective of the stage? What strategy will you use to fulfill the objective? Is there a better solution or method? During this process, you can write this down. After you write it down, you begin with the development, during which you will find things or results that you are not satisfied with. What are these problems that are causing dissatisfaction? How do you plan on correcting them? During correction, you will rethink your design and then produce it. After production, you can try again and see if it has met your objective. If it has not, you'll have to go back to the previous two steps and see what problem you've found and how to modify it and how to redesign it with such modification. It is a cycle process. All these things can be written in the learning portfolio. While writing these things, you may think this way: if I continue to write about my failures, is this alright? Personally, I think it's good. Why? I usually tell my students the following: if what you write is never wrong and you succeed in the first try, I think that is plagiarism. That was never thought out by you. It is normal to encounter problems while doing a project. The key is how you solve the problems after you encounter them. This is the most important part of doing a project. When designing this course, I hope that what we give to you is not too much. That's why in the beginning I'd say that this is a simple part, but we hope that you can complete a complex competition. Why? You can combine these parts together using your own ideas to create your own workpiece instead of just redoing what others have made. You need to think whether there is a better method. This is an iterative process, improving over and over. Let me give you an example. For the tracing task, the first method is to use a single infrared sensor or 2, 3, 4, or even 5. Once you keep stacking them up, you will begin to think, what difference does adding or removing sensors will do? Which configuration is suitable for a certain solution? You can slowly think about these things and write it down. I believe that not only the teacher will want to see this process, but it is also very helpful for your project thinking. We hope that you can pay attention and think by yourself during the whole development process. When you encounter a problem, define the problem yourself. Think about the real reason for this problem and what modification will be made to counter this problem. When you propose a modification, see if the result of this modification meets your expectations. If it doesn't, we need to go back to the previous two steps and redefine the problem. Find the problem, then develop a solution and cycle through it. I think that the most important thing in the learning portfolio in this, I believe that this is what the teachers will want to look at. They want to see whether you've given any thoughts and how you think about it. Let's review the things that need to be written into the learning portfolio. During this process, the first step is to define the objective to achieve based on the topic of the stage. Then based on the objective, what is your development strategy? There will be many feasible solutions for this strategy. Finally, you will decide with your friends the final solution. Then you implement it. After implementation, you should be able to actually place the vehicle on the field and perform testing, checking if there are any problems. During the testing, if there are problems, correct them. This whole process is iterative. You will bring out ideas on functions that you're not satisfied with. What are you not satisfied with? How will you improve it? During the improvement process, You need to rethink your design and then re-implement. After implementation, place the workpiece back on the field. Run it again. Test. If it meets your expectations, keep the good parts, correct the bad ones. Then repeat this execution like a loop until finally optimizing your vehicle as much as you can within the time frame. This is the content that should be written in the learning portfolio. How do you strategize when dealing with a problem? How do you find the real cause of the problem? Then find a solution to this problem. To finally execute the vehicle to